Welcome to day 12 of Python for Beginners tutorial. In day 12, you will learn data structures in Python. In this tutorial, I will delve into the primitive versus non-primitive data structures and lists. Data structures are a way of organizing and storing data so that they can be accessed and worked with efficiently. They define the relationship between data and the operations that can be performed on the data, such as storing data, retrieving data, filtering or querying data, searching data, and so on. There are many kinds of data structures defined that make it easier for the data scientists and software engineers. In computer science, data structures are divided into two categories, primitive and non-primitive data structures. The primitive data structures are integer data structure, float data structure, string, and Boolean. So we have already discussed about such kind of data structures in the previous tutorials, such as data types and variables. But we will focus on non-primitive data structures. Non-primitive data structures are arrays, lists, sets, tuples, dictionary, and files. Those are the non-primitive data structures that could store various types of data in a single variable instead of primitive data structures. But those primitive data structures could store only one type of data. For example, integer could store integer value, floating point string could store string, Boolean could store truth value. So we will focus on non-primitive data structures such as lists in day 12 of tutorial. Okay, let's go. Lists in Python are used to store collections of heterogeneous items in a single variable. Lists are mutable, which means that you can change their content without changing their identity. For example, lists are declared by using square brackets, let's say numbers, and we use square bracket to declare list, which is list. So the variable of the list is numbers, and this variable could store sequence of numbers in this list inside the square bracket. Elements inside lists are separated by comma. For example, 1, 2, 3, 4. So I have list of numbers in this square bracket, and each of the items or elements are separated by comma. And so instead of separately defining each of the items in variable, like for example, x1, y2, z3. Here I have defined three different variables, and I could store those three different values in a single variables by separating comma in square brackets. So this is the way how you could store a sequence of items in a single variable. Lists are built into Python, and you do not need to invoke them separately. The other is lists are ordered. So the items inside lists are sequentially ordered. Now, let me show you how to create an empty list. Let's say the first step is create empty list, which is, so you use square bracket to create an empty list because there are no items in this list. So if you print the type of this variable empty list, it could determine that type of list, object, which is list. So this is one of the type of objects or data. And the other is, let's define an example of list of procedures, let's say, to create beans recipe. All right, here I have a list of beans recipe procedures. And in these procedures, let me print out the list beans recipe. And I can see that the list of are printed out. Okay. Sometimes we will store information in individual variables. So I have already showed you here, because instead of defining variables individually, so we could store in a single variable with a square brackets separated by comma in a list. But often we will be working with several pieces of information that we wanna group together because of their relationship or similarity. So for example, just data are similar, just listing out the procedures how to prepare beans recipe. So this information are similar. So we can organize together using list and we can store in a single variable. So for example, if we were shopping for fruits, we could store each item we are going to buy in separate variables, or we could store all of the items in one list. For example, let's say fruit A, orange. So in this case, I have defined uh, 5 different variables and store 5 fruits. So because those items are similar, so instead of just storing in separate variables, I could create one variable which is list and store in a single variable by defining a list. So I could define a variable fruits. So this fruits variable could store. All right. Now, the next step is how can we access items from a list? The most basic data structure in Python is the sequence. Items are sequentially organized in a list. So because list is storing an ordered sequence of items, each element of a sequence is assigned a number. It is a position or index. So in this case, each items are assigned a sequence of items which is position or index. So the first item in the list positioned as index 0. The second item is index 1. The third is index 2. The fourth is index 3. And the last is index 4. So we can access the items from a list by using the position of that item. So we use the square brackets for slicing along with the index or indices to obtain value available at that index. For example, if I wanna access the third element from the list, so the third element is found at index 2. Print purpose and so I use a square bracket and I pass the position of the item into that square bracket. That is the index of the item. So this means that this is the third element in the list. So the third element in the list is mango. So this fruit is found at position 2, which is the third element in the list. We can also access more. For example, if one access the last element, I have already discussed the negative indexing in the string manipulation. So that is working for lists as well. The last element is the position -1, which is avocado, position -1. And if I want to access, for example, from the first index to the third index, I can pass slicing. And that is the first index is, the 0, the first index 0, which is orange, banana, and mango. Or if I wanna just access every second element, for example, every second element to every second element, the first element is orange, then the second element for orange is mango, that's mango. The second element for mango is avocado. So that is what slicing. This is stride. All right. We can also determine the number of elements in the list using len. We have already discussed this so far. Len, and we pass the list variable into the len function, and we can determine there are 5 items in this list, the number of elements. I just showed you how to access a single element or slice elements from the list. But now I want to show you to print out each of the elements in the list. We can use loop for every element in the process. Print that element. It just iterates through the list and started from the first item to the end of the item and prints that element iteratively until it reaches to the last item in the list. So this is a way how you could access or print all elements of the list. That is the for loop. Iteratively. All right. We could also use another way. Enumerate function is built-in function that help us to obtain the position of the list item as well as the item. So for every I, that is the index and the element or the fruits in enumerate function, we pass that fruits list I into this. Now we could print the index I and the element, the fruit. As you can see here, the position of the element is printed along with the element. So this enumerate function is very useful that help us to obtain the position of the element in the list along with the element. So the first element is orange, banana, mango, apple, and so forth. The other is we can mutate the list because list is mutable data structure. We can modify the items without modifying the list object. So to do this, let me comment this one. For example, if I wanna remove apple from the list, I can use pop function. Pop. So apple is found at position 3, and I pass the position of that apple. And if I print the fruits again, I could obtain 4 items because apple is already removed from the list. That is the way how you can pop. And the other is without passing the position of the item, we can pop the last element. I mean, fruits, dot pop. If you didn't pass the position of the element into this pop function, it will remove the last element from the list. If I print fruits now, I have 3 elements only. The last element is avocado and it is removed because I just use pop function to remove the last element. The other is delete keyword. We could delete using delete keyword. So the delete keyword is delete el, then I use process. For example, if I wanna remove the second position 2, now if I print the process, yeah, the second position of the fruit is 0, 1, 2, mango, and now mango is removed. This is the second method to remove or delete items from list. The other is updating elements of the list. We could update the elements of the list. So we can, for example, if I want to update the last element that's in the list, the last element in the list is avocado. So I can use indexing. For example, the last element in the list is negative. Indexing -1, and I can assign, for example, ananas. Let me print after updating the fruits. Now, the last element in the current list is avocado, but that is updated with ananas. So this is the way how you can update the list items. For example, if I wanna update fruits at position 2 by update. For example, the fruits at position with mango, but now I updated with apple. Okay, so this is the way how you could update the elements in the list. We can also add new elements in the list. To add new elements in the list, we can use append method. So append method always add new element in the last position of the list. So let me process, for example, append was orange. If I print this process again, I could get that orange is appended in the last of the current list process, okay? So this is the way how you can append, because this append is a built-in list method. So we can just add new elements in the current list. The other is store heterogeneous data. Because list is one of the data structures that could store heterogeneous data, different data. For example, let me store heterogeneous data list. So this list stores different kinds of data. For example, the first 2 items are integer. The third element is a string. The fourth element is float. The fifth and last elements are Boolean. But the type of this data is list, one type of data. But this variable stores different kinds of information. So this allows us to store heterogeneous data. So, for example, if you determine the type of this variable is list, but this list variable stores different kinds of data. integer data, string data, floating data, and Boolean data. And the last but not the least concept in this tutorial is combined lists. We can combine two or more lists together. That is, for example, let's say list one. I could have 1, 2, 3, 4, and list two. So I can combine list one plus list two. So I could use the plus symbol to concatenate two or more lists. And when I print combined list, I get 1, 2, 3, 4, 4, 5 through 5.4 the two lists are combined. I mean, the two lists are combined together, and I get one big list. And even I can add the first list into the second and third list, and now I get another big list, which contains different kinds of data. So the three major defining properties of the Python list are that is ordered. Always you should keep in your mind, list is ordered sequence of data or item, and list is also heterogeneous and mutable. It can be modifiable. Because it is heterogeneous and mutable, the list is very flexible than other data types. We need to be careful about the changes we make to a list because they can be very unpredictable. We could break our code or lose our data. So these are today's lesson. I hope you enjoyed this video tutorial. If you have any questions, you can ask in the comment section of this tutorial, and don't forget to like, share, and subscribe. Thanks for watching.